Hello, today we will continue our two-part series in solving polynomials. In part one, we discussed the first two ways of solving a quadratic equation. We talked about factoring and we talked about completing the square. In this video, we're going to talk about using the quadratic formula as a third method for solving a quadratic equation. You can use any one of these three methods to solve quadratic equations. If the quadratic formula is executed properly, it is unnecessary to check the solutions. Before we look at a couple of examples, let's look at the equation and break it down. We are looking at the quadratic equation, and a quadratic equation simply states you have a degree of 2 with decreasing degrees following. With a as a coefficient of x squared, we have b as a coefficient of x, and then we have our constant c. From this quadratic equation, we are able to solve for the value of x using the quadratic formula, which is what we have right here. The quadratic formula states that you take the opposite of b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. I'm not going to get into the proof of that in this video. However, if you complete the square using our definition of a quadratic equation, you will be able to arrive at this quadratic formula. So looking at the quadratic formula, we are going to look at what is known as the discriminant. The discriminant will help you analyze what your outcome will look like before solving the problem. There are times when a question will just ask you for how many solutions there are, and you can use these tricks that I'm about to show you to identify some of the key characteristics of the equation you're working with. So the discriminant is the portion that is under the radical. That is going to be this portion right here, which is the square root of b squared minus 4ac. If the square root of b squared minus 4ac is greater than 0, then you know you're going to have two real unequal roots. And so this means you're going to get two answers for the value of x, and they're going to be real numbers, and they are not going to be equal to each other. However, if the discriminant is equal to 0, then you're going to get one root with multiplicity 2. And this means that you're going to get the same answer for the value of x. And lastly, if the discriminant, or the square root of b squared minus 4ac, is less than 0, you're going to have no real roots. With no real roots, you will have to work with imaginary numbers. Now, we will not get into imaginary numbers in this video, but if you need a refresher, I will link a video in the description below. Now, what's really cool about using the quadratic formula here in its entirety, you are able to use the answers and express them as a product of linear factors. This is saying that by completing this problem and getting the solutions, you can then turn it into the factors if you were unable to factor in the beginning. And we will see how to do that in our final example. Okay, let's jump into a couple practice problems. Okay, looking at our first problem, we have 4 multiplied by the quantity x squared plus 4x plus 4 equals 11. Now we know that we need to get it into the form ax squared plus bx plus c, and so let's start by doing that. And how we're going to do that is we're going to move the 4 over, so we get x squared plus 4x plus 4 equals 11 divided by 4, because what we did was just divide each side by 4. And now what we need to do is bring the 11/4 over to the left side so that we can set this equal to 0. If we do that, we will be left with x squared plus 4x plus 4 over 4 is 16 over 4 minus 11 over 4 equals 0. Now we simplify. We have x squared plus 4x plus 5 over 4. Okay, now what we need to do is look at solving this equation, which is set equal to 0 for x. And we do that by using the quadratic formula, which again is the opposite of b plus or minus the square root of b squared minus 4ac, and that all divided by 2a. So all we need to do is plug in the coefficients of a, b, and c, and once we do that, we'll be able to solve for x, because this is equal to our value of x. If we do that, we get plus 4, so the opposite of plus 4 gives us minus 4, and then we have plus or minus meaning that we're going to have two answers. The square root of b squared, so this is b, which is just 4, and we square that, which gives us 16, minus, we take 4 multiplied by a, in this case a is 1, and we take it by c, and in this case c is 5 over 4. We divide all of this by 2a. 2 times an a again was 1. If we further simplify this down, we get negative 4 plus or minus the square root of 16 minus, if we do 4 times 1 times 5 over 4, that's going to leave us with 5, divided by 2 times a, with 2 times 1, which is equal to 2. And now what we can do is simplify this down. We have negative 4 plus or minus the square root of 11 all over 2. This is equal to x. Our values of x are then x equals negative 4 plus the square root of 11 divided by 2, and we have x equals negative 4 minus the square root of 11 divided by 2. This can be simplified down to negative 2 plus the square root of 11 divided by 2. And this could be simplified down to negative 2 minus the square root of 11 divided by 2. And these are your answers. Very, very simple if you follow the equation. Both of these are equal to x. And so if you plug in this value of x into this equation, you are going to get 0. Similarly, if you plug in this value into this equation, you're also going to get 0. Now, if we take a look at the discriminant, we see that the discriminant was a value that was greater than 0, because the square root of 11 is greater than 0. And what we learned was this tells us that we are going to get two unique real answers. This answer is different than this answer, and they are two unique solutions. And again, we were able to understand this was going to be our solution because we had information about the discriminant located here. Okay, let's look at another problem. Looking at our next problem, we have x squared plus 4x plus 4. Now, we can look at this and see 100% that this could be factored. This can be factored down to x plus 2 multiplied by x plus 2, and our value of x is going to equal a negative 2 multiplicity 2. That's what's going to happen here. Again, if you can see that you can factor and it's relatively simple for you, I'd recommend going that step. However, if you can't see the factor that easy, we can always use the quadratic formula and we're going to get the exact same answer. Now what we will see is that our discriminant most likely is going to be 0 because we are left with the value of negative 2 multiplicity 2. Let's see what that looks like. Using the quadratic formula, you have the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If we plug in all the values for a, b, and c, we are going to get the opposite of 4 plus or minus 4 squared, which is 16, minus 4 times a, which is 1, multiplied by c, which is 4. that all divided by 2a. In this case, a is 1, so it's 2 multiplied by 1. This can simplify down to negative 4 plus or minus the square root of 16 minus 16, because 4 times 4 is 16, all over 2. Further simplifies down to negative 4 plus or minus the square root of 0 all over 2. If we want to continue with this, we know that the square root of 0 is equal to 0, and therefore this term cancels out because there's nothing we can do. If we add 0 to negative 4, we're going to get the same thing to if we subtract 0 from negative 4. So we can just not worry about this and simplify the problem down. We get negative 4 divided by 2, and this is equal to negative 2, which is equal to x. And that is exactly what we got when we factored. Again, you can use any one of the three methods. You can use the quadratic formula, you can use factoring, and you can use completing the square. If you use the quadratic equation, you don't have to guess and check with factoring, and you don't have to do all the steps required in completing the square. You just use this formula and plug in the values of a, b, and c. Once you do that, you solve for x. Let's look at our final example and how we would use these answers in determining what the factors are going to be for the solution. Okay, looking at our last problem, we have 12x squared minus 16x minus 3. And the question asks us to use the quadratic formula to solve for the factors. Now, when solving for the factors, all you need to remember is you have to take x minus the solution. And that's going to be on both factors. Because you are going to get a plus or minus the discriminant, which is greater than 0, or you're going to get plus or minus the discriminant, which is equal to 0. Either way, you're going to get a multiplicity of 2, which means you're going to have two solutions that are the same, or two factors that are the same. Similarly, if you have a discriminant that is greater than 0, then you're going to get two unique factors or two unique answers. You need to do both the plus, which will go in this one, and you need to do the minus, which will go in this one. Let's take a look at what that looks like. We're going to use the quadratic formula. That is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. From there, all we need to do is plug in our values of a, b, and c. Opposite of b, we have negative 16. The opposite of that is 16 plus or minus the square root of b squared. So we have 16 squared, which is 256, minus 4 times a, which is 12, times c, which is a negative 3. So let's put that negative 3 there. Don't forget that a negative times a negative is going to yield a positive. So you just need to be aware of that. And we're going to multiply that by 2 times a. And in this case, that's 12. Now let's simplify. We have 16 plus or minus the square root of 256 plus 144, because we have 4 times 12, which is 48. 48 times a negative 3 is 144. Divide that by 2 times 12, which is 24. Okay, now we further simplify. This is going to give us 16 plus or minus the square root of 256 plus 144 is 400 all over 24. This discriminant is greater than 0, so we're going to get two unique real solutions. And so with that in mind, we're going to simplify. We're going to get 16 plus or minus the square root of 400 is 20 divided by 24. And therefore, this is going to be equal to, if we reduce everything, 16, 24, 4, they all have a common factor of 4. So if we divide 16 by 4, we're going to get 4. If we divide 20 by 4, we're going to get 5. And if we divide 24 by 4, we're going to get 6. Now, we can write this as 4 plus 5 divided by 6 equals x. And we also have 4 minus 5 divided by 6 equals x. Solving for this, we get 9 over 6, and we get negative 1 over 6. This can be reduced to 3 over 2. And these are our two solutions. We have 3 over 2, and we have negative 1/6. However, the question asks us to find the factors. And so what we need to do now is we need to plug in these values into our solution here, into our factors, right? So we take the plus solution, which is 3, 2, and we do x minus 3 over 2. Similarly, we now do your x solution minus your minus answer. In this case, a minus times a minus gives us a plus. 1 over 6 equals 0. And now what we want to do is simplify, because we don't want rational numbers in our answer. What we want to do now is remove the fractions from the problem. So to do that, we need to multiply this term by 2, because that's going to cancel out there. And we need to multiply this term by 6, because that's going to cancel out that term, right? And with multiplication, you can move them all the way around. So this could be written as 2 times 6 times x minus 3 over 2, x plus 1 over 6. All I did was just move the 6 to a different location. And when we do that, we're going to get 2x minus 3, and then multiplied by 6x plus 1. And this is our final answer. This is the solution for the values of x. However, if we want to turn them into factors, we need to follow what we have up here. You take x minus the solution on both solutions when you add and when you subtract. And then what you want to do is remove the fraction. And now you are left with the actual factors of this equation. If you wanted to check your work, all you'd have to do, as we learned before, is set 2x minus 3 equals 0, and we take 6x plus 1 equals 0. You're going to get what we have in our answers here, 3 over 2, and negative 1 over 6. Just remember, when working through, always write out your quadratic formula so you know exactly what you need to do as far as plugging in the correct coefficients of A, B, and C. If you have any questions, please leave them in the comments below. If you learned something, please like and subscribe, and we'll see you next time.